acetate. I have, how many elements are involved in acetate?
3.
I have carbon here and there. I have oxygen there, and I have hydrogen. I have 3 different elements and more than one atom. That's why it is considered to be polyatomic. So how do we do if we need to name this? Take a look. In your table, you might want to include the iron phosphate. I use it quite a lot, and this is the formula that you must write. The name is phosphate. It has 1 less oxygen than phosphate, but they both have the same oxidation state, -3. So right now, I'm going to choose an element. Right now, I want to work with that element over there, calcium. Calcium has an oxidation state of 2 positive, okay? And right now, I'm going to give you 3 examples of how to name compounds that involves polyatomic ions. So I will use this table and I will highlight the polyatomic ions that will be joined to calcium. I will use chlorate, chromate, and arsenate. So I'm going to give you right now the first example. I have calcium, and the first one that I highlighted was chlorate. That is the first example that I will explain. Calcium, what I have to do in the first place is writing the symbol and the oxidation state of each. Calcium, you know, it's Ca2+. Chlorate, how do we write chlorate?
ClO.
Like that, ClO3 negative. There it is, ClO3 negative. The oxidation state is -1. So it is Cl. Remember that the L I do looks like italic because I want you to understand that is chlorine. And this is O for oxygen. That's not a 0. And the subscript is 3. The oxidation state is 1 negative. So that's the first step that you do. You replace words by the symbols and the oxidation states. What comes after is just joining the elements. Make them smile, okay? A happy face. Now that they are being joined, you just need to write them next to each other, like this. But, wait a minute. Okay, like that. Now, you have to think of what to do with the charges. The charge of 2+, where am I going to move it?
To chlorate.
To chlorate. Okay, I will put 3 marks on there and you will indicate in what position I'm going to put it. So, could be in the position 1, in the position 2. In what position am I going to put the 2?
Position 3, you're going to place parentheses.
Here, right, in the position 2. Okay, and then I have to use parentheses. Good, you remember. So, that's true. You must move the 2 to the other side, like that. I don't know how to do this without messing things. No, like that. Yeah, I'm just gonna move the two, okay? You know, it goes to the other side, but right to the end, okay? You don't put it in the middle of chlorate. You put it right at the end, okay? Always at the end. So that 2,4 calcium comes here after the chlorate. But now, as you said, because I have the 3 and 2, they are together. It looks like a 32. So what you do instead, you need to make a separation between them. And we need to use parentheses. The parenthesis comes here. And the other comes here because remember, you have calcium in one side and chlorate in the other side. They are different things. If I put the parenthesis here, that's nothing, you know. Well, it's something because this is known as ozone, but in the end, that has no sense, okay? So the parentheses must be written here to separate the chlorate from the calcium and to separate 3 from chlorate from the 2 that is coming from calcium. Now, after this, what do I have to do with the 1 negative? Do I move it? Do I ignore it? What
Just
can I
ignore
do?
it.
Just
Just
ignore.
ignore it, okay? Remember, when you have a charge or an oxidation state of 1 positive or 1 negative, you can ignore it. It's going to be fine. I'm gonna put it here. Now, after we have done this, we need to name it. How can we name this compound? Just the first element, it needs to be named first, and then the polyatomic ion comes in second. So the name for this compound is going to be calcium. And how do you call the polyatomic ion there?
Chlorate.
Chlorate. Okay, like that. I see no pens. Yes, yes, yes. Sorry about the noise. Those are people from the street. Don't know them. So you can see that, right? It's kind of easier, in my opinion. It's kind of easier since you have all the names for the polyatomic ions. So you just have to recognize this. Okay, to recognize all the polyatomic ions, and the names are given in the table. Now, for you, it's easier, remember, because you are we are in virtual classes, so you can have the table with you. But in the end, what I used to do was forcing my students to memorize them. So it can be hard at first, but in the end, when you get to work a lot with these compounds, you're going to like memorize it just by doing homeworks. Anyway, we can start with a second example that says calcium and what is the other polyatomic ion?
Chromate.
Chromate. Okay, calcium and chromate. So what I do in the first place is to write the calcium and the chromate, the formulas of each with their oxidation state. Calcium, that is Ca2+, and chromate, that is Cr O4, and the charge is 2 negative. So what do we do in the first place?
We join in.
We join them, we try to make them happy because they make our life happy, a happy place. Okay, you join them, so you have CaCrO4. Now, perfecto, ¿verdad? No sé qué pasa. There it is. Okay, we have CaR4. Now, what happens with these charges? 2 plus and 2 minus.
We cancel them.
Because they are the same number, but also they have different symbols, we need to cancel them. So, if you cancel them, no subscripts need to be written, just the name. How can we name this compound?
Calcium chromate.
Calcium chromate. Okay, I'm going to write another name and you will tell me your opinion. Is it correct or incorrect to write like this? Espera un momentito. What if I write like this? Calcium 2 to indicate the oxidation state, and then the chromate. Is it correct? Is it incorrect? What do you think?
I think it's incorrect.
Incorrect.
It is incorrect because calcium has only one oxidation state. So you don't need to specify that it uses a charge of 2 because that is the only possible charge that it can use. That's why this, you don't need to write it. But in the case of having transition elements with different oxidation states, it will be needed. So yes, that one was incorrect. Now let's try it with the other part, the other example. Calcium and arsenate. Okay, espérense un momentito. Okay, calcium and arsenate. First, we write the elements and symbols with the oxidation state. Calcium, you know so far that is Ca2+, and arsenate. Arsenate is there in the table, is here, okay? AsO4. And the charge is -3. So the first step to create a compound is to make them happy. So this is the compound that is formed. Now, the 2 from calcium, where are you going to put it?
You're going to place parentheses and next to the 4.
Parenthesis next to the 4. That is correct. So the parenthesis comes here to separate arsenate from calcium. And the 2 from calcium comes over there. Now, where do I put the 3 from arsenate?
In calcium.
Next to calcium.
Calcium, next to calcium, just like that. After this, how can we name it?
Calcium arsenate.
Calcium arsenate. Yes, calcium arsenate, just like that. Okay. Now, this is kind of very simple because we were working just with calcium. Okay, remember, calcium is quite easy to work with, but still, those are good examples, you know. Now I'm going to try more examples, but instead of calcium, I will be using 2 polyatomic ions. Okay, so I'm going to copy this table. I will copy this table. Okay. Now I'm going to work with ammonium, and I need 3 volunteers that choose 3 polyatomic ions from the columns below. Okay, 1 from each column.
Phosphate.
Phosphate. I forgot to bring, I forgot to bring phosphate. I'm gonna put it there too. Just give me a second. You said phosphate. So another volunteer to choose from column 1 and column 2.
Nitrate.
Peroxide.
Sorry, I couldn't hear. You were saying at the same time.
Nitrate.
Nitrate. Okay, so nitrate is here. And for the second column,
Oxalate.
oxalate. I heard two. I heard oxalate and I heard peroxide. Which one do you choose?
Oxalate, miss.
Okay, let's do it with oxalate. Oxalate. Guys, oh my God, sorry. So now I'm going to work with ammonium. I'm going to write ammonium's formula here. NH4, and the charge is 1 positive. So in the first example, I will be joining ammonium and nitrate. Ammonium, which has a formula of NH4 and the charge oxidation state of 1 positive, and nitrate, that is NO3 and the charge is 1 negative. Okay. So in the first place, we need to make them happy. No, sin letter. We need to make them happy. We join them, the happy face, smile, and we're going to have NH4, NO3. Gerald, what happened with the charges?
Ignored.
We ignore the charges. Exactly. We ignore the charges. You don't need to crisscross them because they are both 1, or you cancel them. It's the same. In the end, no subscript will be written. Now, what is the name of this compound?
Ammonium nitrate.
Ammonium nitrate. Do you have a question so far?
No,
Okay. Now let's do it with part B. Let's do example B. And I will be joining ammonium and oxalate. I almost never use oxalate. I like that you have chosen it. So Formulas. For ammonium, NH4 in the charge oxidation state 1+. For oxalate, C2O4 in the oxidation state 2-, 2 negative. So what is the first step, Tirsa?
We cross the one in the -2.
Yes, we're going to move just the one that has the -2. But the first step, remember, is you join them, okay? You join them with a wonderful smile. So you have NH4, C2, espérense, C2O4. And now, as you said, you put it to the other side, the 2 from oxalate. Where are you going to put it? Jennifer, where are you going to move that to? Jennifer?
Open parentheses.
In ammonium, say open parentheses in ammonium, and the 2 is going to be placed after ammonium, like that. What do we do with the 1, Jorleni? What do we do with the 1 that I highlighted over there?
You ignore it.
We ignore it. And how do we name it?
Ammonium oxalate.
Ammonium oxalate. Okay, ammonium oxalate. The other example, ammonium and phosphate. Okay, what is the formula for ammonium and the formula for phosphate? NH4, oxidation state 1+. Phosphate is
PO.
PO4.
4.
Okay, it ends in ATE, so it is 4. And the oxidation state is going to be -3, like that. The first step is
To join them.
to join them. Thanks. So you write them together, NH4, PO4. What do you do with the 1, Brian?
Ignore it.
You ignore it. What do you do with the 3, Nicole?
We pass it to the other side after parentheses, after ammonium.
Parentheses after ammonium. Okay, so there you go, the parentheses in ammonium and the 3 from phosphate written after, like that. And now the name. Volunteer for naming it?
Ammonium
Ammonium
phosphate.
phosphate.
Ammonium phosphate. Thank you both. Okay, now here in the bottom, I will do one extra exercise. I will just be writing the symbols, okay? Okay. What do we do in the first place here?
We join them.
You join them, you write them together. Okay, like that. Now, what comes after? What do we do with this sheet? Where are you going to write it?
You pass to the other side and place parentheses.
In the other side, next to iron, next to sulfur, or next to oxygen?
Next to oxygen.
Next to oxygen, so you put it here. And because now they are together, place the parentheses. What do I do with these two?
We put it next to iron.
You put it next to iron. And how can we name this?
Iron.
Iron 3.
This is 3.
Sulfate.
Sulfide.
Iron sulfide. And as you said, iron 3, because iron is a transition metal. So we need to specify the charge. So that will be the name. If you don't write the number in Roman numerals, that would be incorrect. Just like that. Do you have a doubt on this one? Now, without procedure, try to name these ones. Without procedure, without doing any procedure, just trying to name that one. Just by taking a look.
Copper, in parentheses 1, permanganate.
Permanganate. That is correct. Copper, 1 permanganate. And the formula? What do you do with the charges?
Eliminate.
Cancel them.
You cancel, you eliminate the charges. So the formula will be just joining them. And the name, as you said,